Okay, this is the rest of the review, starting with number 10. Okay, determine the argument of z, for this problem right here. So it does say over here to graph z, so I'm going to graph it first. So 4 minus 3i, so you got 4 and then negative 3. So your job is to tell me, there's the vector, that's c, c's done, is the argument. So we're going to find this angle. Now with complex numbers, your answer, so you cannot say no negatives, no south of east. You have to give me an answer between 0 and 360. And you want to go counterclockwise to get that. So the arg of z, you're going to go arctan of 3 over 4 because it's the vertical over the horizontal. Be nice if you could see what I'm doing, huh? So we're going to go arctan here, arctan of 3/4. 36.86, so we'll go 36.9, and then we're going to take 360, so it's 36.9 is the reference angle. We're going to take 360 minus that, so it's about 323.1. So 323.1 degrees is the argument of z. So I want to say arg of z equals. Calculate the absolute value of z, which is the actual length of this. So that is 4 squared and 3 squared. 16 and 9 is 25, so the z absolute value is 5. And then there's the vector. So given negative 3 plus 2i and w 4 plus I, find each of the following. So z is negative 3 plus 2i, and that's minus w 4 plus I. So that is the additive inverse. So we are going to add negative 4 and negative I. So negative 3 and negative 4, that's the real part. That is negative 7. And then 2i and negative I is I. That's your answer. Now this is z times w, so we're going to multiply, which means we're going to FOIL. Keep in mind that you can double check any of these on your calculator. But I do want you to show work on the test. So this is negative 12, this is negative 3i, 8i, and 2i squared, if you do FOIL. So 2i squared is really negative 2. So negative 12 and negative 2 is negative 14, and negative 3 and 8 is 5i. Answer. So we got z, which is negative 3 plus 2i, divided by w, which is 4 plus I. The conjugate of 4 plus I. So to get rid of the I in the bottom, you need to multiply by the conjugate, 4 minus I. So the top of the FOIL is negative 12 plus 3i plus 8i minus 2i squared, which makes that a 2. All over 16 minus I squared, which makes that plus 1. So that is negative 12 and 2 is negative 10 plus 11i over 17. So your answer then would be negative 10 17ths plus 11 17ths I. It's a weird answer. Let's just check that. I don't know. Better check my answers in my answer key. What number was that? See how they have it right here? That's never. You should never write it like this. You have to separate. These should be separated. So I do not like their answer in the back. So the distance between z and w. There's a couple ways to do this. I really personally prefer the distance formula. So I would think of this as an ordered pair, and I think of w as an ordered pair. Oops, that's a 1. 4 and 1. Negative 3 and 2. Okay. So the distance formula is 4 minus 3 squared, and 1 minus 2 squared for a 7 squared, which is 49, and 1 for a square root of 50, which is 5 radical 2. So this is the one that's going to be cost a lot of points if you don't know how to do it. So number 12, pay attention. So square root of 2 is about 1.4. So we're going to say this is a 0.5 here. We'll say this is 1, and we'll say this is 1.5. So this is bigger than the unit circle. So 1.4 is about right here. That is what, let's just double check my work here. Square root of 2. 1.4. All right. 1.4 is here. Negative 1.4. It's about right there. Draw your vector. So this angle is pretty large. It's not, I mean, it's going to be in the 300s. Okay, so every time we multiply by this, we're going to get 300 something. So first thing they want to do is, what is this length? Okay, so if you made a triangle, this is square root of 2 and this is negative square root of 2. So to find that length, we're going to do the Pythagorean theorem. So we're going to have radical 2 squared and radical 2 squared, which is 2. Why is this so blurry? It's having trouble focusing. So radical 2 squared is 2, and radical 2 squared is 2, so this is square root of 4, which is 2. The arg is arctan of radical 2 over radical 2, which is 1. So the reference angle is 45, but this is not a 45-degree angle. This is 360 minus 45. So the angle, or the argument, is 315 degrees. So when I've said, what is the arg? Okay, wait a minute, w squared. W squared means you have to multiply these two things. W squared technically means if you added another 315 to this angle, where would you be? So 315 and 315 is 630. Where is 630? Let's see. If you just added another 315, well, I think it's easier just to do 630. So this is 360, 450, 540, 630. I think you're going to end up on this y-axis down here. It's going to be down here. When you go around 315, you're going to be right there. So let's see if we're right. Let's do the work. I feel like I should do the work. Radical 2 minus I radical 2 times itself. FOIL. Radical 2 and radical 2 is 2. Radical 2 and radical 2i is negative 2i. Negative I radical 2 and radical 2 is negative 2i. And negative I radical 2 times itself is positive I squared times 2, which makes that negative 2, which cancels the 2's. So this is negative 4i. So when I said it was going to be down here, I was correct. Now, this length was 2. So every time, okay, so when you have a length of 2, so this didn't happen with the unit circle because the unit circle's lengths were 1, like that length was 1 times 1, so it was 1. But this is 2, so the length of this one was 2. So every time you multiply it, you're going to multiply this by 2. So basically you had W, the first W, had a length of 2. The second W had a length of 2. So you multiply those to get 4. That's why it's 4i. The angles, you take 315 from the first W and 315 from the second W, and you add these for the 630. So the second vector is W squared is 630 degrees with 4. But 630 degrees ends on this y-axis, and it's got a length of 4. So the complex number for it is 0 minus 4i. But if I would have asked you for the absolute value of W squared, it would have been 4, length of 4. So this one's going to be double the length of this one. So the argument of W squared is just 315 and 315, which is 630 degrees. Now, another answer that you could get for that, you could say 270 degrees, because that's where it's at. So the argument of W cubed would be 315 plus 315 plus 315 for a 945 degree angle. Now, where is that at? Let's see. This is 360, 720, 810, 945. You would be right there. So the next one should have 945 degrees, and it should have a length of 8. 2 times 2 times 2. So it would have a length of 8. And so you'd say 945, or you could say 225. That's where it's at. 945 or 225. So what did the answer in the back say? I'm curious. Did they say 225 or 945? Actually, they said 225 or negative 135. They must not like my answer. Now, going back to the definition says the smallest angle that you should, the smaller angle. So if I said which one's the smaller one, 945 or 225, you would want to say the 225. Smallest one that's coming from the x-axis. So you probably wouldn't use the 945. So back to this one. I probably wouldn't use 630. I would use 270 because it's the smaller of the two. All right. I hope you understood that. Just FYI, what would W cubed be? The length. So this first one was length was 2. The second one was 4. So W cubed's length would be 8. But what if I actually just wanted W cubed? What if I would have said, what is W cubed? So W squared was negative 4i. So W cubed would be the one that's over here. You probably figured it out using your radicals, but I'm not asking you that right now. All right, write each complex number in polar form. So the first thing we do is find R. R is the square root of 3 squared and 4 squared, which is 5. So that's the first answer. Then to find the angle, we're going to take arctangent of 4/3. Which is 53.1. Now, that is not your answer. That's the reference angle. What quadrant is this in? If they're both negative, I'm so sorry, my video is not on here. If they're both negative, it means you're in the third quadrant. So you're going to take 180 plus 53.1 for a 233.1 degree angle. So R is 5. Your argument, oh, we're not done. Let me read the problem here. Write each complex in its polar form. So now that we know these two things, now we can write it in polar form. So it's 5. I'll do it to some blue. So we have 5 parenthesis cosine of 233.1 plus I sine 233.1. That's the answer to A. Sorry, this B's going to have to come over here. So now we're going to do 3i next. 3i. So the complex number. So what is R for 3i? Well, just looking at 3i, it's like right up here. It's got an R of 3. The radius is 3. And the angle is 90. So this would be 3 cosine 90 plus I sine 90. No work needed. When you do products, you want to multiply the R's, so 4 times 10, and you want to add the angles. You're going to go 10 degrees plus 75 degrees. So it's going to be 40 cosine of 85 plus I sine 85. 15. Write the complex number in rectangular form. Rectangular form is another word for complex form. So you need to know your unit circle value. So 150 unit circle. It's got to do with the 30, so it starts with radical 3 over 2 and 1/2. But it's in the second quadrant, so the x-coordinate is negative. So this is 6 times negative radical 3 over 2 plus 1/2 I. Then we're going to distribute. So 2 cancels with 6. That becomes negative 3 radical 3. 6 times 1/2 is 3. That's your answer. To draw a vector, you got to go to 210, which is right here. And you're going to go 2 rings. So that's your answer, and you're done. This one is 180. That's going straight left. And we have to go 4 rings. 1, 2, 3, 4. That's all you have to do. Okay, you don't have to do this one, this one, and this one. Okay, so spring breakers sight a shark in the ocean but are safely on the beach watching where it is going. The shark travels 80 degrees north of east for 12 kilometers. So he's traveling 80 degrees north of east for 12 kilometers. X and Y axis. Then he's going to turn and travel 20 degrees south of east. That's this way. For 8. To the nearest kilometer. How far is the shark from where the people first started tracking its movements? So like we want to know this. So east-north chart. So the first one is 12 kilometers, 80 degrees. 12 kilometers, 80 degrees. Now when it says 20 degrees south of east, be careful. It's going this way. Okay, so we're still going to have the 8, but 20 degrees, you can't use 20 because that's in the first quadrant. You can use negative 20 or you can use 340. Let's just go ahead and use negative 20 because we turned and went to the fourth quadrant. Do you guys see that? We turned into the fourth quadrant. So this would be 8 sine of negative 20. So we've got 12 cosine 80, parenthesis, plus 8 cosine negative 20 equals, that's 9.601. Now to do the next one, we press second enter and bring that back up. I'm going to change my cosines to sine. Sine there, sine there. Now that's the right side. So that's 9.082. So when it says to the nearest kilometer, if you did redraw 9.6, 9.0, you're in the over here. So we're trying to find this right here. This is what we're trying to find. Nearest kilometer. What is it? So you're going to get that by taking 9.601 squared plus 9.082 squared. (9.601) squared plus 9.082 squared. 13.216. Oh, to the nearest kilometer would be 13. So you're about 13 kilometers from where you first started tracking its movements. Now, to the nearest degree, in what direction should the shark head to turn directly to its starting point? Okay, this is the start. This is where he turned. He turned right here. So if you put another XY axis right here, which way did he turn? He turned south of west. It does say to the nearest degree, so we're going to figure that out. So it's arctangent of the 9.082 from the chart above. So it's arctangent of 9.082 divided by 9.601. 43.4. South of west, but it does say to the nearest degree. So we'll go 43 degrees south of west. And that is your worksheet.